Hi everybody, welcome back to this course on Internet Technologies. I'm Vardan and today we'll be studying about subnets and subnet masks. Let's start by understanding what exactly a subnet is. In the original design of IP addressing, each IP address had two parts, the network portion and the host portion. But as networks grew, this just wasn't enough, and administrators needed more flexibility within their networks. That's where subnetting comes in. So a subnet is short for subnetwork. It's essentially a division of a larger network like a class A, B or C network. It adds a third level of hierarchy between the network and the host. So now you have network, subnet, host. So this allows an organization to manage its IP addresses more efficiently by splitting one large network into smaller and logical pieces or subnets internally. It essentially improves routing performance, it simplifies administration, and it reduces the wastage of addresses. Now, to make subnetting work, we need something called a mask. A mask is essentially a 32-bit binary number made up of a series of ones followed by a series of zeros. The ones represent the part of the address reserved for the network and the subnet portion, and the zeros represent the host portion. So there are two types of masks. One is a natural mask. This is the default for class A, B, or C networks, and a custom subnet mask, which allows administrators to extend the network portion and create subnets. Without a mask, a router wouldn't know which part of an IP address is the network or subnet and which part is the host. This mask is essential for routing decisions and internal address management. Now, by default, every IP address has a natural mask. Routers use this to split an IP address into its network and host portions, and the default masks are 255.0.0.0 for class A, 255.255.0.0 for class B, 255.255.255.0 for class C. Now, how does a router decide which one to use? So it does this by looking at the first octet of the IP address. If it's between 1 and 126, it's a class A address. Between 128 and 191, class B, and so on. So to actually separate the network part from the host part, routers use a bitwise AND operation between IP address and its mask. So for example, with 10.0.0.20 and a mask of 255.0.0.0, the AND operation keeps only the network bits, giving you 10.0.0.0 as the network address. Now, when you need more flexibility than natural masks offer, you use a subnet mask. A subnet mask extends the network portion of the address by borrowing bits from the host portion. Those extra bits are then used to identify individual subnets. For example, instead of using the natural mask of 255.255.255.0 for a class C network, you might use 255.255.255.192. That additional 2 bits in the subnet mask allow you to create 4 subnets within your class C network, each with its own range of host addresses. Subnetting lets you efficiently manage IP addresses, avoid wastage, and organize networks into logical sections without needing to apply for more public IPs. So let's understand this with an example. Take the IP address 144.16.72.57. By default, since it starts with 144, it's a class B address whose natural mask is 255.255.0.0. But let's say we want to subnet it. We apply a custom subnet mask, that is 255.255.192.0, and here the network portion was extended by, let's say, borrowing 2 bits from the host portion. And Now the router performs a bitwise AND operation between the IP addresses and this subnet mask. So here we've got a binary representation of 144.16.72.57 and 255.255.192.0. Now the AND operation keeps only the bits where both are 1, and that's how we get the network address of the subnet 144.16.64.0. So any host address from 144.16.64.1 to 144.16.127.254 would belong to this subnet. This is how routers use subnet masks to efficiently route traffic within and between subnets. Finally, why use subnets instead of multiple address classes? Subnets are essentially an internal concept. They let a network admin divide a single IP network into multiple smaller and logical segments without the outside world needing to know about it. When traffic moves through the internet, external routers only see one route for the entire parent network, not for each individual subnet. If you used multiple address classes instead, every new network you added would require a separate entry in global routing tables. This adds overhead and increases router memory requirements, and it slows down the routing process. That is why subnetting is efficient. It keeps routing tables small and scalable while giving network admins complete control within their internal network. And with that, we've come to the end of this lecture. And in the next one, we'll dive deeper into how to make subnets, and we'll learn about VLSM and CIDR. And thank you for joining in, and I'll see you next time.